looked at first like an attack just on hospitals in the UK, but it's now becoming clear that this malicious software has run riot around the world. Russia, the United States, and many points in between have been hit by what's now a common form of cybercrime.
Ransomware has become a tool of choice for an awful lot of criminals simply because it's very, very easy to make money very quickly. You can buy ransomware online for as little as $39.
So how does ransomware work? Well, it often arrives in the form of a link in an innocuous-looking email. When you click on that link, the malicious software is downloaded and spread rapidly through your network, locking up all the files on it. Then a message flashes up on screens warning that if you want your data unlocked, you'll have to pay a ransom, often in Bitcoin, the virtual currency. The irony is that security experts think a hacking tool allegedly leaked from America's National Security Agency in April may have been used by the attackers. Microsoft warned about the threat this vulnerability posed, but said anyone who'd installed a security update to Windows software the previous month would be okay. The Health Service will point out that it's just one of many organizations around the world affected by this attack, but it now faces what could be a lengthy process of cleaning up its computers and making the network safe again. Rory Catherine-Jones, BBC News.
So sorry for the technical problems. You would have been seeing the video, but we couldn't get the embedded link to actually work, and clearly we didn't test out the fallback. So if you're like me, you're often scared from all the continuous attacks on businesses, on individuals, collection of data. The most recent one, Experian, of course, but dating back from the one that kind of started the entire trend, the one that really hit everybody's radar was the Sony Pictures one a few years ago. It seems like we truly are constantly under attack, both from an enterprise business perspective, but even from an individual perspective as well. A few years back, James Comey, the former FBI director, made this quote that I like to kind of constantly use every time I talk about this topic. There really are kind of two types of companies in the world, those who've been hacked and those that don't yet know that they've been hacked, which is to say that we all are under attack. And it's an incredibly costly impact to businesses that speaks to the very bottom line of every business in the world. And compounding that, when companies are actually compromised and when hackers get into company systems, oftentimes it takes hundreds of days before that breach is detected, which means they have all of that time to do whatever damage and inflict whatever rampant impact to your business that they intended. So that's terrifying. Government agencies around the world agree on relatively few things, but when it comes to cyber threats, one of the most common responses that government agencies advocate, these are the agencies that are responsible for protecting government systems against attack. They all agree that application whitelisting and whitelisting management is the most effective, or one of the most effective mechanisms for protecting against cyber threats. The problem is whitelisting is incredibly hard. Most organizations either don't do it or do it really badly. In order to be successful, you have to be constantly vigilant. You have to maintain that list. You have to keep it updated. As the things that you want to trust change, you need to make sure that you remove trust for things that you no longer want to. And most organizations just find it very difficult to approach that problem space. There are a number of reasons behind that. The first one that I would point to is within many organizations, even today, the use of digital code signing to actually ensure that the integrity of code that's running, your applications, just isn't used prevalently. Many internally developed line of business applications at even large companies, and frankly, I would admit, even at Microsoft, some internal line of business applications are not digitally signed. This extends even to software that's coming from independent software vendors. So you will often find ISVs who build software for enterprises, And they may digitally sign the installer, but they may not digitally sign all of the code that actually gets installed on the system. When that happens, it makes your job of trying to maintain a whitelist way harder. The other factor, when we're talking about the breadth of software that a typical organization deploys, which can be upwards of hundreds or even thousands of applications, many of them coming from ISVs who have suites of software, you don't necessarily want to trust everything that comes from your software vendor. Which is to say, you may license a particular application from Microsoft to use in your organization, but you don't want to necessarily trust everything that comes from Microsoft. And if you're just trusting the Microsoft signature, that allows anything that's coming from us to run on your systems. So with that, we want to talk about the technologies within Windows that are enabling you to address the whitelisting problem. And I'm going to hand off to Nazmus Saqib, the program manager in Microsoft who's responsible for our whitelisting technologies.
Hi, everyone. So if you've been following the Windows 10 security story, you will know that we've had application control since TH1, since the first release of Windows 10. We called it Configurable Code Integrity, and it was packaged as part of Device Guard. So if you've used Configurable Code Integrity, you're already familiar with a lot of the features that we'll kind of talk about throughout our talk today. But with the recent spate of attacks that we've seen, we are making application control a first-class citizen of the Windows Defender suite. So with the Fall Creators Update, we're introducing Windows Defender application control. We are having whitelisting policies that are applied at a deep layer in the kernel. So if you're familiar with an older technology like AppLocker, which didn't apply to kernel drivers or as well to non-interactive processes, Windows Defender application control gives you coverage for those sorts of executables. It's a single machine-wide policy. So you'll make a single policy that applies to a device. If you're interested in things like user-based or group-based controls, you'll still need to consider using AppLocker for those particular scenarios. Application control applies to script hosts and MSIs as well. And for PowerShell, any PowerShell scripts that are not authorized automatically run in constrained language mode, so reducing the attack surface from PowerShell scripts, which, if you've been following the news, is a big part of kind of the vector for a lot of the newest threats. So touching on Device Guard a bit, we'll cover, our talk is kind of split into two halves. So we'll talk initially a lot about application control, and then we'll talk a bit about virtualization-based protection for that application control. And the point that we really want to drive across is that these features can be deployed independently of each other. You don't need one to deploy the other. You can deploy application control on any Windows 10 capable system. You don't need to worry about hardware capabilities like virtualization support if you're worried about application control. So the compatibility for application control is basically every Windows 10 system. So a brief sojourn through the history of the technology to kind of give some context for the things that we'll cover today, especially the new things that are coming in the Fall Creators Update. When we started off in Threshold, we were really focused in on a narrow scenario. We're focused in on high security devices, things that were that had restricted workloads, something like a kiosk, a really locked down system that you might hand to an executive. And we had tools to help you make those really locked down policies. You could play in PowerShell and create a policy that was specific to signers and file hashes. And that gave you a lot of control and a lot of security because all your rules were explicit. You knew exactly what you were allowing and what you're not allowing. But that also led to a lot of manageability overhead. As you were thinking about workloads that were perhaps not as locked down, it made it much harder to deploy application control. So we've been slowly working on addressing that manageability gap. So in RS1, we focused on previewing a feature that we call Manage Installer. This is a capability that we'll demonstrate later on, or Dune will help demonstrate, where we automatically allow anything that you're deploying from an application catalog management system like, say, System Center Configuration Manager, or a third-party tool which you may be using, as the capability is generic. We also worked on some of the hardware-based, making the hardware-based capabilities easier to deploy with a device guard and credential guard readiness tool. So with the creators update with RS2, we introduced full support for Manage Installer. We have a UX that Dune will show in SCCM to make deployment of the Manage Installer feature super easy. And we also introduced Windows 10s, which we'll talk a little bit more about later on. And with RS3, with the fall creators update, we've introduced cloud-driven application whitelisting. We have a new option in application control that removes the burden of manual policy creation entirely if that meets your needs for the workloads that you're looking for. We use the intelligent security graph to classify applications into known good, unknown, and known bad. And if you've selected this option, we'll only allow things that our intelligent security graph identifies as being known good to run. So talking about that a bit more, this works in conjunction with everything else in the policy. So, it works with rules that you've already defined explicitly. So think of it as another option that you've set in the policy. If you have to allow a specific application that you've written, like some line of business app, you can totally write an allow rule to do that. But you don't have to write, 100 rules to allow Office and Chrome and Firefox. Those things will just work because we have a single knob in policy to go and do that. We always update the intelligence, and we periodically update the reputation we're assigning to those executables so that we're responsive to the data signals that are coming into the ISG. So this is ideal for those lightly managed scenarios, for systems that you're running on a day-to-day basis where folks have a much broader application base that they're looking to run. Things like Office and Chrome and Firefox, all those utilities are easily allowed. And we'll have Intune and SCCM integration coming really soon. And if you've seen Brad Anderson's talk, it really is super, super simple. It's down to 2 clicks if you want to go and enable this application control based on the cloud. And we'll jump into the first demo. So I have a system that has the ISG feature enabled. So the system is locked down to only run Windows code, store applications, and anything that has good reputation. So 7-Zip is a well-known application. Let's see what happens if I try to run it. Zip installs. It's not blocked from running. And look, it runs. What happens if I try to run an application that doesn't have any reputation? So this is a foo exe that I wrote earlier this morning. And look, it's blocked. So it's so easy to do. If you look at, this is the dog food environment of Intune. So how easy is it to enable this feature in practice? I'll zoom in a bit more, just so that folks have an easier time seeing it. You can go and create a device configuration profile in Intune. I had an application control profile set up earlier this morning. Let's look at the properties. It's a setting. We've introduced this new node, which is Windows Defender Application Control, alongside all the other Windows Defender settings in Intune. You choose to enforce or audit the policy, and then you get to decide if you want to enable trust for apps from the ISG. If you don't do that, and you choose to enable the feature, it's locked down to just run Windows and Microsoft Store apps, which is very restrictive. but we give you the option to do that if you really want to lock it down to such an extent. But if you want to just enable Windows apps, store apps, and anything that our cloud thinks is good, like 7-Zip, like Chrome, or Office, all you have to do is hit enable, hit OK, and you're good to go. It's, I think, the first demo we've done for application control that doesn't have any XML or PowerShell. So it really is focused on giving you that manageability.
So again, just to, I think I see a question, but let me talk first, and then, just to reinforce what Saqib just said. So this, especially for enterprises or smaller businesses or those that are just finding it intractable to begin to adopt whitelisting, this technology gives you literally a 2-click option for configuring it in exposed through Intune. Other applications can also do it. Those 2 options just set up a policy on your behalf that allow Windows to run, so it knows what rules to set up to just so that Windows won't break, and then adds this option for the intelligent security graph to power what other things are allowed. And the important thing about leveraging the intelligent security graph is that that changes over time. So as our awareness of software and the reputation of that software might evolve over time, we can change the score on that software so that if something has been previously identified as good, that subsequently we determine has drifted out of a known good state, we can start blocking that application on an ongoing basis. And what that'll do, the effect that'll have on your clients, is that if a user goes out and tries to download an application that was previously known good and try to install it on their app or on their device, it'll get blocked even though some other user might have been able to install it on their device a week ago. And then, we periodically reevaluate the reputation score on the devices where an application had already been installed, and so we can stop those applications as they become known bad from running in your enterprise. And so leveraging the power of the cloud and the intelligence that Microsoft has from our antivirus solution, from solutions that are in the Bing organization, as well as from SmartScreen, we can bring all of that intelligence together to drive a whitelisting technology for you to kind of take that initial step for deploying into those more difficult to manage environments.
So that's Intune. What about SCCM? Did we get any SCCM folks in the room today? Hey, that's a lot better than we've seen. That's great. Hi, folks. I'm Dune. I'm on the SCCM team. Really happy to be out here to do a little SCCM demo for what we've been doing to improve manageability of application control on the SCCM side. The first thing you're going to notice, well, when I cut over in a moment, is that our UI still says device guard. And we're working on changing that because there's been a big point of confusion with our experience that it says device guard. Does that mean there are prerequisites? We try to make it really clear in our docs, but people still tend to go, I wonder, do I need all these hardware requirements to deploy the SCCM policy? The answer is no. So we're really happy about the rebranding and rebirth of app control because it's going to allow us to be a little more clear about what the requirements are for our policy. So SCCM leverages this piece that they've mentioned that Saqib was just speaking about called Manage Installer. Manage Installer lets you automatically trust applications that are deployed through your management tool. So if you're managing your applications through SCCM, lock down devices that receive SCCM deployments. Any new software that is deployed by the SCCM client gets automatic trust. So hands up if you're deploying apps for SCCM today. Keep your hand up if you're deploying 100% of your SCCM apps today. We've still got a couple hands. OK, that's good. So there's some interesting scenarios that we run into when we see customers that are deploying some but not all of their apps. And one point that we really wanted to get home today was that for your most secure devices for SCCM customers, if you want to roll out app control, it is important that you kind of think about taking full ownership of the applications that you allow to run on your devices and think about how you're installing those other apps that don't come from SCCM and think about whether there's a way to deploy them through there. Because if you want to deploy application control, the main paths to making it easy for yourself and by far and away the easiest is to leverage the managed installer technology and deploy through SCCM. We do have, as of the 1706 release of SCCM, another piece that'll make it a little easier that I'll show you in a moment as well for those applications that, for whatever reason, you can't deploy through SCCM. What our policy does, I'm actually going to cut over to the demo so I can show you this live. So the console will be familiar to many of you in the room. And we have a device guard policy node, like I said, that'll be changing in name to application control. Don't freak out when it does. It still does the same thing. And what our policy does is has a predefined circle of trust in the same way that the Intune policy does. Now, of course, SCCM has our own client binaries that we need to install because we're not relying on the MDM stack that's built into Windows and is Windows signed. We need to also be able to authorize our own client and include that in our circle of trust. So the SCCM circle of trust includes the SCCM client binaries, our dependencies, Windows OS components, and store apps, and then any applications that are deployed through SCCM after the policy is processed on the device. And so that's the circle of trust. We've been talking to a whole bunch of customers about this, and it seems like the right circle. If you don't think it is, I'm really interested in talking to you after this. We've been iterating on it quite a bit and trying to get it just right. And we do know that there's some applications that, for whatever reason, can't be deployed through SCCM, and so we have a little bit of a way to get around that as well. I'm going to walk through the wizard, and then I'll talk to that right now. So we give it a name. You only have to choose enforce or audit. We saw that in Intune as well. It's the same switch, but I really wanted to emphasize just how simple that is. Because hands up if you've tried to write and author some, say, AppLocker or Code Integrity XML in the room. Okay, less people than SCCM this time. Wow, the times there are changing. So that's really painful, as I'm sure those 4 people can attest. So we really want to get away from that as much as possible, and this is a way for you to do that. Now, Managed Installer is in a way tiptoeing along the line between manageability and security in the direction of manageability, right? If things get easier to manage, they're always inherently going to get less secure in a way, and the inverse is also true. So, of course, Managed Installer says, I trust my management authority and my installation authority, and if my installation authority somehow gets compromised, then I accept that the installation authority will be able to do whatever they want on my device. So that's kind of something that you have to accept with the feature. And it does make your life a lot easier, because you're deploying apps through SCCM anyways, and SCCM's security has always been a priority, so our infrastructure is not easy to exploit. And it does let you make your life a lot easier in terms of your app deployments and whitelisting them. So you choose audit or enforce. And then we get to inclusions. So inclusions is a way that you can add explicit paths to files or folders on your client devices that we then include in the policy when we process it on the client. That's a one-time scan and include of a file and folder on a device. If whatever we find at the location that you point to is properly code signed, we'll use that data to identify the binaries. And if you upgrade those binaries, if they're signed, we will also trust future versions of those binaries. If they're not signed, then we're going to look at the hash of the binary, and then if you change them at all, then we're going to say, doesn't match, you can't run. So trying to be a little secure by default there. This is the way that you can get around some applications that you might, for example, have in a fat image that you're deploying. Because, like I said, Managed Installer only works after the policy has been processed. So the policy gets processed on the client. After it's been enabled, software gains trust. But before that, there's no way for the software to get trusted. So inclusions can help you with that. So if I wanted to add a folder, I can actually browse to a remote computer. In this case, I will pop over to localhost, which is a cheat, I know, but it gets the point across. And then I can navigate through the file system on that computer and point to a file or a folder. And my permissions are still applied and honored, as you just saw there. So let's say I wanted to pop over and trust everything over SQL Server, under SQL Server. It'll pop all these in. It's actually the same experience as you might, if you've ever done app packaging and deployment with SCCM, it's the same experience as we have for app detection rules. And then that just snaps into the table here, and then we include that in your policy. And so those are the features we've been doing in SCCM. We like to think that it makes it a lot more manageable. And if you do have applications that you're not deploying through SCCM that you could be, and you're interested in deploying application control, I'd strongly encourage you to consider moving those in to really take control of your app ecosystem and understand that whitelisting means understanding exactly what's running in your environment.
Yes, go ahead.
One time, when the policy is processed.
So when it's processed, it looks at all that.
Yep, that's it.
Yeah. So for those of you who missed what the question was, so the question was on the rule that he just authored, is it evaluated one time on the client at the time that the policy is applied, or is it continuously watching for that folder? The answer was one time. So basically when that policy that Dune just authored comes down with the rule saying I want to trust things under the SQL Server folder, when that policy is applied, it'll look at what binaries exist in the SQL Server folder, and it'll automatically whitelist those. Yes, sir?
The ISG, any chance of bringing that into SCCM?
Oh yeah, I'm so sorry. I totally forgot to mention that. Yeah, so we're bringing in ISG support in SCCM as well. It's just not in there yet. And we're bringing in something else I'll let you guys talk to later as well. What's that?
Oh, yeah.
Also, currently we schedule, I had to get the okay there, sorry. Currently, we require a reboot to enforce the code integrity policy. Now, Fall Creators Update and beyond, app control policies don't require a reboot, or you can opt out of requiring a reboot, which is, again, a security trade-off because application control is only applied when a process begins running. So if you have things running and the policy is applied, technically there are things running that are not enforced. But in the same way that AppLocker has always worked that way, it gives you the option to do this now. So instead of coordinating a reboot, we'll just apply the policy for Fall Creators Update and above devices. Coming soon. Question?
So, another way around, we have managed installer features
Yeah, for Intune?
down management.
Yeah, so the question is, will we have, so the opposite of the last question, so will the managed installer feature be available for MDM and Intune? So I guess there's two parts, and Dune can talk to specifically Intune. The technology in Windows for managed installer is generic. So any software deployment technology in either MDM or SCCM or a third party that competes with Microsoft in that space, they can all conceivably leverage managed installer. The main piece that SCCM has done has been, they did have to make a small change to their client to handle certain edge cases. So the technology that actually does the installer has to be somewhat enlightened a little bit. So there's, there may be some MDM/Intune work to make that work that we do want to do. We actually are looking, however, at building a more secure approach to doing kind of a managed installer solution for the cloud that we aren't prepared to talk about today. But
2018.
But and specifically, so what I'm kind of dancing around is all of these options are allowing you to balance manageability versus security. Managed installer, while superior to, sorry, let me back up. ISG, the intelligent security graph option, while worlds better than having no whitelist policy, is still pretty broad. It allows a lot of things to run. It allows things that are reputable, but they're like, you're not sure that you really want it in your enterprise. Managed installer is a huge step up from that, but there are cases where it basically opens up certain attack vectors on the client where it can inject into the process for SCCM and thereby gain a foothold onto the client. So there are vulnerabilities that these technologies essentially kind of open up that still have to be exploited. So you still have to, it still has to be attacked, but there's a trade-off that you're making in security and manageability. With the cloud-based approach, we ideally can come up with a solution that doesn't require heuristics on the client to figure out what's allowed to run and provide a much more secure solution. And so that's ideally where we're going. Aaron Margos.
I wouldn't, I wouldn't call it opening up vulnerabilities.
Sure.
Because it's, you're whitelisted. Anything you apply is better than not having whitelisting at all.
Absolutely.
Right? So the question is, how tightly are you doing
That's
it?
correct.
And there are things where you're not tightening it down as much as you could. But that's, I would not use the expression opening up vulnerabilities, because
you're
that makes
absolutely
it
right.
sound like you're worse off than if you don't do anything at all.
No, you're absolutely correct. Poor choice of words. Yes?
So to add to that, is there any plans to add the possibility to select a type of category type of app, like blocking game apps or
Yeah.
other type of non-good enterprise apps?
Yeah, so the question is setting policies by like categories of apps. The challenge, so we've heard this request a number of times. There's a bunch of things that make it challenging to do that in a robust way. So A, when we're talking about Win32-based apps, legacy applications, there's just no, there's very little good app identity to those types of apps. There's almost no classification to them, and so it's very difficult to maintain that kind of management. If we look at the store, like store-based apps, they have metadata that categorizes them into these categories, but they're kind of at the whim of the publisher of the application. So there's not a kind of strong categorization mechanism that's enforced in the store. And today, the exposure of that categorization details on the client are not always available to us for enforcement. So there would be some work to enable that type of scenario. We're absolutely interested in looking into better ways of kind of managing at broader categories. One of the things that we've explored and we're looking into is also, rather than going with kind of categorization of apps, looking at management of capabilities. So apps that leverage a specific capability on the device, we could control in a more granular way.
I wanted to call out also that with the Intune application control policy, because that has trust for, like I said, the operating system and store apps, your store app deployments from Intune will work out of the box with the Intune app control policy. So it's not the same kind of a managed installer thing, but your Intune app deployments for Windows, for Microsoft Store for Business, I should say, applications will work.
So we'll take these last two questions and then we need to continue.
Will Intune sidecar deployments count as that trusted installer at release?
Good question.
So yeah, I would say we're still in the planning phases of how we enable a managed installer type scenario for Intune. So sidecar potentially is one mechanism that we could leverage where the sidecar itself is a managed installer. The real answer is we don't yet know. We're evaluating a number of different options for doing it. We'd like to do one that's actually more secure and more robust than how we've implemented managed installers today. And hopefully we'll have news in a subsequent Ignite, maybe next year. That
the short answer is no.
Okay.
Not out of the box. The long answer is
maybe.
The Intune management extension. The Intune management extension is for more than applications as well. It's not specifically an app installation authority, so I'm not sure that it's something we go after as that. We'd like to look at what the best ways are to deploy some of the apps that you might need to deploy with the management extension today, and then figure out how we can close those gaps and integrate into that story rather than betting on the management extension in the long term, if that makes a little sense.
It does. Thanks.
Okay, thanks.
Okay. One more question, then we move on.
In terms of licensing, is there any additional requirement to license your clients for the Intune option or for the SCCM option, other than the default Windows 10 Enterprise license?
So you would just need, you need licenses for Windows, and you need licenses for your management tool. But you don't need, if you're thinking of like Windows E5, unless one of these guys disagrees,
Yeah.
I don't believe you need that.
Okay, thanks.
Okay. So recapping kind of where we started at the very beginning with the ISG option. So again, if you have an organization who either has tried but failed to implement whitelisting, they've backed away, they're afraid to do it, Their users have become accustomed to installing any random apps they download from the internet. ISG is a great solution to raise the security bar, the security posture of those clients in that type of an organization. Managed installer is a huge leap above that from a security perspective, because now you're saying, rather than trusting anything that has just reputation that Microsoft has determined is reputable, I'm going to say that only things that are coming through my managed software catalogs can be installed and deployed and run on clients. You can kind of see where we're going. Like, these technologies are trying to help you take your organizations, dip your foot into the water of whitelisting, and then improve your processes over time to get to a point where you can raise the security posture of your org and secure more of the devices and tighten down what's allowed to run. The most secure approach, which I kind of talked about way back at the beginning of the talk, is really getting to pervasive adoption of code signing and writing explicit rules, which, as Saqib mentioned, is kind of where we started with our application control feature as part of Device Guard, but it limited the applicability of that feature and where you could actually practically deploy it, because maintaining that kind of a whitelist in a Win32 application world is still really a difficult problem. So we built, all the way back in Threshold 1, we did build tools in-box in Windows to help you approach the problem of taking your existing line of business apps that may or may not have been code signed in the past, taking your ISV apps that may or may not be code signed, but you don't want to trust everything that they signed, and leverage our tooling to actually add a signature for your organization that basically stamps the approval that says this is allowed to run in our org. Again, it doesn't matter whether it's already been packaged, it doesn't matter whether it's coming from your internal line of business app developers or an ISV. You can use these kind of generic technologies to augment your apps with a signature by leveraging catalog signatures. And so what I'm going to now show you is how you can do that. So there's a couple of things first. So crafting the policy for your whitelist is step number one, the difficult part to get your foot in the door. We've tried to introduce some options that will allow you to approach that problem more easily. One of the things that we've done is we've actually manifested within Windows a bunch of sample policies that you can use as a starter. So if your organization is more tightly secured, you have fairly robust and mature IT app deployment and management solutions, you can actually start to do more explicit whitelist policies. So you will find these on, I think actually with with the creators update in this past RS2, we actually added a couple of policies. We've continued to add additional policies. So these are the set of policies samples that we've provided in the upcoming fall creators update. And so let me just.
The fall creators update introduces and allow Microsoft policy. So if you have a scenario where you want to allow Windows plus all Microsoft signed code, such as Office, any other of our development tools, for an example, that policy will let you do that.
Yeah. So you can see the list here. So we have a bunch of samples you can start from. The one that I want to specifically focus on is this one that's default Windows audit and default Windows enforced. So you could take this policy and actually apply it on a system, and it would lock down that system to only run Windows drivers that have been signed by the Windows Hardware Qualification Certificate, and then store apps. So for those of you who are familiar, and I'm kind of jumping ahead a little bit, for those of you who are familiar with Windows 10s, which was released with great fanfare fairly recently, Windows 10s actually leverages this same technology to achieve that lockdown of the device to protect it from running things that are potentially bad. it is effectively the same default Windows policy, but with additional exception rules that block things that are actually Windows signed that can be used to attack a system, but are important for a lot of scenarios. So let's take a look at the. Actually, let me get out of that. Sorry. Okay. So this is the XML from the allow Windows in audit mode policy. And the main thing I want to highlight is the actual set of rules is relatively straightforward. We do have a bunch of redundant rules because if you want to allow flight signed builds, so if you're in the Windows Insider program, you have to trust an additional set of certificates, so it kind of doubles the number of rules. But the default actually allows for either of those. So this is our default policy. This is the one, again, that's coming directly from the Windows build system. We've also had for some time in the Microsoft Store for Business a portal that's dedicated towards device guard. Windows Defender Application Control. The text here will also have to change. And one of the things that we've had on the site for quite some time is also a sample policy. I've already downloaded the sample policy here, and I want to open that kind of side by side with the one I just had, just to highlight there is effectively the exact same policy with one notable exception. So here I'm looking at the default policy I just downloaded from the Microsoft Store for Business, and the only key difference is these two rules that I'm kind of highlighting here that you can see under the device guard signing service tenant. So it adds to that default Windows policy a couple of signatures that are managed in the Windows Store for Business on behalf of your tenant that are unique to your tenant that you can use to sign application catalogs and deploy them with your apps. And if you deployed this policy, then anything that you've managed and have signed through this portal would also be trusted. So that's great if for organizations that don't do code signing, the device guides, the signing service in the Windows Store for Business is a great way to start to do code signing. The other problem that you will face is your existing line of business applications that are not currently signed according to that policy. So I'm going to show you how to take an existing line of business application and actually prepare that so that it will run on your devices that are enforcing this default Windows policy that came down from the device guard signing service in the Windows Store for Business. So to begin with, I have downloaded 7-zip, which is a common file explorer, a zip technology that is popular but comes from the internet. It is not code signed. But it's already been packaged. I don't want to have to incur the cost of having to repackage all the applications and signing them myself. So I want to basically augment it with a signature. So to begin with, let me just show I'm on a system that has a policy applied to it. It's in enforcement mode. I'm going to double click, and 7-zip will not run. It's blocked. So what I'm going to do is I'm going to take my 7-zip installer, and I'm going to actually come over to another device. Okay. So now I'm actually on a device that is running with the ISG option. So 7-zip is actually one of the applications that has reputation. So it's still kind of applying an application control policy, but it's a little more relaxed than the one that I'm trying to enforce over on my production device. Okay, so, and actually all of our commands, when we were testing this out beforehand, are already there. So first, I want to just make sure 7-zip is not installed. I don't see it in the start menu. It's definitely not there. So we provided, beginning with the initial release of Windows 10 in Threshold 1, a tool called Package Inspector. And what this tool does is it will essentially start running in the background and monitoring file write operations on a drive that you specify. So here I've started Package Inspector to monitor file writes to the C drive. And now I'm going to take my 7-zip installer. I'm going to drag it onto my C drive. And that's an important step because we want the installer itself to also become trusted. So that now has been captured and identified by Package Inspector. We wrote that file to the drive. I'm going to run the installer. And again, it has reputation, so on this device, it'll run just fine. It was blocked on my other device. I don't actually need to restart. So 7-zip is installed. I'm just going to launch 7-zip just to, because for me it's a good practice because there are applications that will download additional things on first launch, etc. So just make sure it runs. Excellent. All is good. And now I'm going to issue the stop command for Package Inspector, and it is going to spit out 2 files. Okay, in the System32 folder, not where I want it, but that's okay too. So let me open up the first one, which is, so there's 2 files created. One of them is a catalog definition file, CDF, and that's basically going to show me these are all the file write operations that were identified during the period where Package Inspector was running. So I can eyeball it, make sure it looks like, yep, the things that I expect to have been captured are the things that were captured. This was then used to create a catalog file, which is also in that same location. So now what I need to do, I'm going to copy the catalog that was created to my USB drive. All right. And flip over to my enforced system, just for a moment. Oh, yep. Okay. So here is the catalog that was created. You can see the creation time. Saqib's device is on Pacific Coast time. That's why it has a 12:01 timestamp, but it's 3:01 here. So here's the catalog. This was created from that 7-zip installer. If I look at the properties, there's obviously no digital signature on the catalog yet. So I'm going to upload the catalog to the Microsoft Store for Business. Okay. Yeah. Let me just refresh, make sure I don't have to, okay, I need to re-authenticate. I suspected that might be the case. Okay, let me do that again. So I'm going to upload the catalog to the Store for Business. Okay, it is completed. It's a very small file, so it says 0 megs, but it is there. So now the sign option has become enabled. So I'm going to sign that catalog and download the resultant catalog. I'm just going to save it to my desktop. Extract it. It comes down as a zip file in case you uploaded a number of different catalogs. Okay, so same 7-zip catalog, but this one now has a signature appended to it. I don't know if you can read it. I can zoom again. So it says BSP Partner 1. That happens to be the name of my tenant in the Microsoft Store for Business. So it was signed with a certificate unique to my organization.
Jeffrey's had that tenant for years.
Yes, I have. Okay, and so I'm now going to take that signed catalog and apply it to the system using a utility called sign tool.
And this is all stuff you can automate, of course, if you're going to
Using
get creative.
SCCM, yes.
If you wanted to use SCCM to script all this, you certainly could. Though again, our policy is easier.
Okay, so what I need to do is specify, so I'm using this tool, sign tool, which is just to essentially register that catalog with Windows, using an option for catdb or the catalog database. And then I just need to give it the path to the catalog file, which I think was signed files 7-zip catalog. So just to show you my command before I run it. So signtool.exe, catdb, the path to the catalog file. Oops, sorry, I hit an extra character. Okay. What did I do wrong here again? I forgot. I'm getting that error again. It was the path. Okay, sorry. I need to run it from a different location. Sorry. Sign tool has a little quirk. So I need to actually run it from where my catalog is. All right. All right, sorry. Okay, so minor modification to the command, but nothing major. I just had to run the tool from the location where the catalog file actually exists. So that has now been added to, that catalog now has been added to the catalog database in Windows. It has the signature for my tenant from the device guard signing service. I should now be able to take 7-zip and run it without doing anything else to make it work. I didn't add any explicit rules. I didn't set up managed installer. I'm not using the intelligent security graph on this device. I have a locked down policy that allows Windows to run and allows things signed by my organization's tenant certificate. And fingers crossed for the demo gods. That was further than we got last time. That's a good sign. Complete the install. And 7-zip runs.
All right.
Yes. So that is how, leveraging the tools built into Windows, you can actually start to take your existing application suite and augment them with signed signatures for your organization. So great, I have an enterprise that has hundreds or thousands of applications. How do I approach that problem in the first place? So you can leverage tools like SCCM, for example, to actually automate this process of running and monitoring installers on a kind of clean system, and actually, for example, deploy all of the applications in your catalog and build a single, in your software library, thank you, and actually build out a single catalog that is like, I'm going to whitelist everything in my software catalog as a starting point, and then from that point on, as I deploy new applications, I can actually generate these catalogs as I deploy applications through SCCM, create a catalog using package inspector, sign the catalog file, and distribute that along with the application itself through SCCM. So you can see how the problem of code signing is at least something you can start to address. And that's the thing that I want to get across to everybody in this room, especially if you have not yet approached application control or whitelisting within your organizations, and you find it just too difficult because of these problems of the lack of code signing, or the lack of trust in the signatures, and the sheer number of applications. You need to start to wrangle control over your software library if you want to get to a world where you have attestable control over what's allowed to run on your devices.
The question is, could I do the same thing with my own PKI, with my own?
Yes. Yeah, so the question is, can I do the same thing with my own PKI? The answer is yes, and in fact, I kind of cheated. Sign tool would not have been allowed to run based on my policy. So the policy that's actually being enforced here has a signature that, has my own signature that's been added to it. So let me show you how to make that work. Okay, so as I said, so here we have sign tool. If we look at the properties of sign tool, I had added a signature to this previously that was my own, so I kind of cheated, as I said. So this was not my tenant signature. I have my own PKI. I've applied my signature to it. I actually overwrote, in this particular case, the existing signature. You can actually add additional signatures. So sign tool comes from Microsoft. It normally would be signed with a Microsoft certificate. I overwrote that with my internal PKI device guard cert. So what I'm going to do now is leverage PowerShell to actually scan and generate a application control policy for the applications that have my cert. So I'm going to use a PowerShell commandlet called new CI policy. And I'm going to, we'll call this lobapp.xml. I'm choosing a certificate level for creating the rule, so it should grab the certificate information. And I'm going to scan the location where that sign tool app was placed. And I think that's the, and then user PEs. Okay. And this will spit out another policy on my desktop that I can show you here momentarily. And all of these commands are well documented online, so you can find how to generate these scans. So I now have a new policy that was created by that scan, and you can see there's a single rule. So anything signed by my custom internal PKI device guard certificate, and that is the only signer rule that was created. So it's a very simple policy. Now, if I took this policy and applied it on my system, it would not work because it is not allowing Windows and all those other things. So what I'm now going to do is actually take this policy and just merge it with my other one. So again, I have my default policy. That was the Windows rules plus my tenant rules and my LOB app policy. And now I'm going to run another command called merge CI policy and create a merged policy, merged.xml. You specify the paths to the two policies that you want to merge. So I'm going to start with my default policy and my new LOB app policy. And that is it. There we go. I now have a policy that has the rules to make sure Windows runs. I have my policies for my tenant. My BSP partner one, it actually has two signers, so that's two signatures, so it actually has those. And then my custom one. So now I can take this policy and actually apply it on the system, and that is what I actually did. So a way to get started is either is just taking the default policy that we have in the Windows folder that I showed you earlier. You can start with that one. That has, again, all the rules for allowing Windows to run. Scan a folder that has applications that you've used your internal PKI to sign, and merge those two policies, and you now have a policy that would lock down that system to only allow things, again, with Windows signature and your signature. Okay. Outstanding. Okay, so to recap, so we have those PowerShell utilities. They've existed since threshold 1. You can continue to use those for creating and managing custom policies. We've shipped those example policies in Windows that you can use as a starting point. You can also download the custom policy from the device guard signing service in the Windows Store for Business, and then leverage your SCCM or group policy to actually deploy your catalog files, deploy your custom policies for Windows Defender application control.
So we've covered a lot of concepts today. We've covered explicit rules, as Jeffrey just showed. We covered ISG earlier on in the talk. We covered managed installer. How should you guys think about all of these different concepts? If you were to hopefully deploy very soon, how would you think about deploying, mixing and matching these things and deploying them? So explicit policies gets you a lot of security, high security, but it requires some work, some tinkering in PowerShell, so it's not a simple, highly manageable two-click solution, right? ISG gets you a lot of manageability, gets you going in 2 clicks, but it's a broad base of trust. You're allowing a lot of things. You don't have as much control. Manage install, it kind of tries to strike that balance, right? It's tied to your application catalog deployment solution, and you get a bit more manageability and a bit more security than you get with ISG. So as you think about the different workloads in your enterprise, you think about the different systems that you kind of have, what are the constraints that you should think about? So you should think about your security stance. How secure do you need any specific device in your enterprise to be? How secure should your secure admin workstation be? How secure does the receptionist system need to be? Think about manageability, like how big is your team? How much expertise do you have in PowerShell? How much time can you devote to deploying application control? And then you think about application variability. What are people running in your organization, right? Do you have a lot of developers? Do you just have people using simple productivity tools? Are you using a lot of internally developed tools, a lot of line of business software? So these are the sort of constraints and requirements that will inevitably come up when you think about a practical application control deployment. So how does that work? What are the cheat sheets we can kind of give you? So let's think about a fixed workload. So think about something that has, something like a kiosk or a secure admin workstation, or a very secure admin workstation has, say, 1 or 2 very specific purposes. It's tightly managed. You've bought the device. You know what hardware and software it's supposed to run. Very low churn. For a scenario like that, a lot of the tooling that we have is great for getting you to that highly secure stance. You can use the PowerShell tooling to get that really secure policy, something that's explicitly defined that you can protect with signed rules. Then think about something that's a fully managed device, something that you might think about an exec using, something that you care about the security of. You want a really high posture, but you want something that's a bit more manageable, so that if the exec wants something deployed through Software Center, through SCCM, that you can easily kind of meet that request, then turning on that knob of explicit rules and say SCCM, that makes a lot of sense for that sort of a device. When thinking about a more lightly managed device, when I think about this scenario, I think about the system that I tend to run PMs at Microsoft run, or I see my colleagues in the marketing team run. So we get a lot of, folks have a lot of carte blanche on what they get to run from the internet. So I get to run, Office, I get to run tools like 7-Zip. If you have that sort of environment where folks are used to getting things from the internet and running software, then using ISG makes a lot of sense. If you're already deploying software through SCCM, your line of business tools, turn that knob on. And you might need explicit rules still, just because, as I mentioned, ISG gives you that such a broad kind of control. There may be things that you're doing, like deploying explicit deny rules, just because you're trying to meet some other corporate policy around, say, licensing or compliance. And then, if you're in a world where you're thinking about BYOD deployments, how does application control apply to that? We can deploy a policy in both enforce and audit mode. And so I'd encourage you to think about deploying an audit mode policy that does enable manage installer, enables the ISG integration, because if you're integrated with a tool like, say, Windows Defender ATP or any other kind of reporting tool, you can get more of a visibility into the things that are running in your organization. With our integration with Windows Defender ATP, things that register as application control blocks do show up as warnings in ATP. So if you think about that, that means that even if you're just auditing systems, you're not blocking execution of anything, you do get some visibility in ATP on users that are running unknown software on a BYOD device, which might be interesting from a forensic perspective or just following up from a compliance sense. So Windows 10S, we touched on it a bit. We use a lot of the same technologies as we've kind of described to sort of build the lockdown for Windows 10S. So in many ways, you can think about 10S as using a Windows Defender application control policy that we've put in the hard work of defining and then protecting to lock it down, to essentially run Windows, to run Microsoft Store apps, and to also block some of the things that we've seen that get around our protections. So we're blocking things like CMD and PowerShell. PowerShell's been involved in some of the attacks that we've seen recently, just to make sure that you get that strong control. You only get apps from the store, and we have a curated driver store as well, just to make sure that the drivers that you're getting really do actually go through our WCL tests. Third-party drivers are blocked. So you get a very secure experience. So you get a very high security stance. You don't get to run Win32 applications, so the application variability is low, but in many cases that might work for you if you're using only store apps and Microsoft Store for Business apps. And you get a bit more of a simplified, manageable solution, because you don't have to create this app control policy. It's just sort of there by default.
So kind of bring it now to take us home. So Windows Defender application control, as Saqib described at the very beginning of this talk, actually has been around since the beginning of Windows 10. It was a feature that we called configurable code integrity, which was a sub-feature of device guard. But by coupling it into the device guard umbrella, it led a lot of organizations and a lot of IT professionals to misunderstand that the two features actually are separate. So we have application control, which is an incredibly powerful utility, can be run on any Windows 10 device. That's what we've been talking about for the last hour and 10 minutes. Has no additional hardware requirements, etc. The second half of what was device guard is this virtualization-based security feature that introduces a mitigation against kernel memory attacks. And it does that by taking the code integrity process that actually validates everything that's going to run in the kernel and isolating that process into the virtualization-based security space, into the secure container. And that is enforced using the hypervisor, which runs below Windows, to ensure that the actual OS and the kernel can't attack code integrity itself. So that you can conceptually think of code integrity as now running in its own kind of special environment, isolated and protected against attacks in the normal world Windows. The reason it's still relevant to this talk is code integrity is the process that Windows Defender application control leverages. So the rules that were created and all those things that we were doing through SCCM and with the ISG and with the explicit rules are leveraging that code integrity process that runs within Windows itself. Hypervisor protected code integrity further protects the kernel memory space. So code integrity, that process that's doing everything to enforce Windows Defender app control, runs in the kernel. By implementing hypervisor protected code integrity, that memory is now protected, and that ensures that the code integrity process that is going to be doing this Windows Defender app control enforcement cannot be attacked through like memory attacks. So if you have buffer overruns, vulnerabilities in kernel code that could otherwise be used to attack the Windows kernel, once you turn on hypervisor protected code integrity, those memory attacks are no longer applicable. And it does that by ensuring that memory code pages in the kernel space are never writable and executable at the same time. And so when a kernel driver loads, if you're not running hypervisor protected code integrity, that kernel page loads up into memory, and it can be writable and executable. An attacker could exploit, could take advantage of a vulnerability in a kernel driver, get access to kernel memory, and once it has access to the kernel, it can do anything. It can attack the code integrity process itself, thereby disabling all of your protections against application control rules. It can attack pretty much any process in Windows, so game is over. So let's look at how this kind of works. So the traditional stack has the kernel with the Windows platform services running on top, and then your applications running in that next layer. A typical attack vector will be exploit something in an app, use that app to then take advantage of an exploit in the platform services layer, or jump directly into an exploit in the kernel through some vulnerable driver. And once you've done that, you own the device. With hypervisor protected code integrity, again, we're leveraging hypervisor itself and hardware virtualization to isolate and segment this kind of secure system container, which is on the right-hand side here, and physically separate it from the normal high-level OS, so the rest of the platform layer. And importantly, the kernel on the left-hand side now, again, those memory pages are never writable and executable at the same time. So when a driver is loading, it's going to allocate a bunch of memory as writable. It's going to load up the driver. It's then going to hand off those memory pages over to, and the hypervisor transfers those memory pages over to the system container, the secure container on the right-hand side. Sorry, I should be using my other hand. So it transfers those over to the right-hand side there. Code integrity validates the code pages, make sure they're signed properly, they haven't been tampered with, the code that is present on those in each of the pages is what was expected. It will then mark the page as execute only, no longer writable, and hypervisor transfers it back over to the normal high-level OS, and now it'll run in the kernel, but cannot be written to. So even if you had a driver that had an exploit that would have allowed a buffer overrun, that could no longer be used to gain writable, executable memory access in the kernel. And so your kernel itself is now protected against entire classes of attack. This is particularly critical going back to WannaCry and Petya and those recent attacks, and many of the other attacks that have occurred over the last several years, because leveraging hypervisor protected code integrity, and especially leveraging it in concert with application control, would completely block those attacks on a Windows system. I'm actually not going to talk about the device guard readiness tool. We included these slides for your reference. A bunch of links to other topics and information about Windows Defender Application Control and Device Guard. And that is it, gentlemen. So, and lady. Thank you very much. We'll be up here for any other questions. Since we were taking questions throughout, you can feel free to come up and talk to us.